So I have here 4 sketches of different trapeziums. Okay, so this is a trapezium. Each of these shapes are trapezium. Now they are trapezium because we have 4-sided shape, so there's 4 corners and 4 sides, and they all have one set of parallel sides. So I've drawn the arrows to show which lines are parallel to each other. So these ones have the parallel sides here. This one has the parallel sides here. This one is here, and this one is there. So these are all 4-sided shapes with one set of parallel sides, and that's what makes them a trapezium. So what we're interested in now is to find the area of each of these trapeziums. Now, I've done here in general terms with letters, so A, B, and H, so that we can change the value of A, B, and H to find the area of any trapezium. Now, all of these trapeziums have the same numbers, okay? And I just want to show you which numbers correspond to which letters, okay? So 5 and 11 are the 2 parallel sides. So you can see 5 and 11 on the parallel sides, and here I've got A and B. Okay, now I could have had 11 at the top and 5 at the bottom, okay, and that would have been fine as well. If I had B as 5 and A as 11, that's okay. They just need to be the parallel sides. You can see that I've done the same thing here, so 11 and 5, so you can have A and B, 11 and 5. So A and B, always the parallel sides, 5 and 11, again A and B. And here again, 5 and 11, they are the parallel sides, so they are my A and B. Now, this height, okay, sometimes it's going to look different. So sometimes it's going to look like it's diagonal like this. It might be going across, okay? Now, this height is the distance between, or the perpendicular distance between the parallel sides and the other parallel sides. So this is a perpendicular line to the 2 parallel sides. So notice how this is supposed to make a right angle here and a right angle there. And it will be the same for these ones as well. If you notice how I'm drawing this one, it's making if I extend my parallel line, it's making a 90-degree angle here. Again, I can think of a 90-degree angle there as well. And it's the same here as well. So if you were to extend the parallel line, we're looking at a 90-degree angle there. Okay, same thing here, 90 degrees. Same thing here, 90 degrees. Okay, so extend the parallel lines, and if it's 90 degrees, that's the height that we're looking for. So you can see for each of these, my height is 3. So my height is 3 here. My height is 3 there, it's 3 there, and it's 3 there. So remember, the height is the line that's perpendicular or 90 degrees with the parallel sides. Okay, so this is the parallel side. Sometimes you might need to extend the parallel side to show that it's 90. Okay, but you don't really need to show it, but you need to know that that's the one, that's the height. Okay, now the formula, okay, it can be written in a few different ways, and the way I like to do it is I like to say A add B, and then we have to divide by 2, and then times it by whatever the height is. Okay, so for each of my trapeziums here, A and B is 5 and 11, or 11 and 5, either way around is fine. I need to divide that by 2 and then times it by the height. So my height for all of these is 3. So I have 5 add 11 divided by 2 times by 3. 5 add 11 is 16, so 16 divided by 2 times by 3. 16 divided by 2 is 8, so 8 times 3, and this is going to give me 24. My units are in centimeters, so I have centimeter squared. Right, so remember, the height is the line that makes 90 degrees of the parallel sides. A and B are your parallel sides. We're going to look at volume of prisms now. Now, I have 3 prisms here. This is a triangular prism. This is a cuboid, which is also a prism. And this is a trapezium-faced prism. Okay, now, they are prisms because they are 3D shapes, and they have a cross-section. Now, this cross-section here is a triangle. If I was to have a parallel cut somewhere here, okay, anywhere along here, if I was to have a parallel cut, I would have this same triangle wherever I made the cut. The same can be said here. If I make a parallel cut somewhere around here, and I will have the same 2x5 rectangle wherever I have made the cut. And it's the same here for this one as well. So this trapezium that you see here, if I was to make a parallel cut through here, the same trapezium will be seen again there. So that's what makes them prisms. Now, to find the volume of prisms, what we need is the area of the front face, or the area of this cross-section, and area of this cross-section, And then once we have the area, what we can do is we can times it by how long it is. Okay, so we can times it by how long each of them are. So let's find the areas first. The first one is a triangle, and I can see that 4 and 3 are perpendicular here. So 4 times 3 divided by 2 will give me the area. So 4 times 3 divided by 2. 4 times 3 is 12, divided by 2 is 6. So I have 6 centimeters squared for the area. Now the volume would be this area, so I'll write the 6 centimeter, I'll actually highlight this. So this part here is 6 centimeters squared, so let's write that down. Now when I know the area, what I can do is I can multiply it by how long it is. So 6 times 10 will give me 60, so 6 times 10 equals 60, and that's the volume, and volume is centimeter cubed here. So that's my answer for the first one. Now next one, I have a cuboid, so I have a rectangular face here, so 2 times 5. 2 times 5 will give me 10. 2 times 5 is 10. That's 10 centimeters squared. Let's write that down here as well. So 10 centimeters squared, and that's the area that I have for this rectangle here. When I know the area, I times it by how long it is. Okay, so 10 is the area of the cross section. 10 times 7 is 70. Okay, so 10 times 7, 70 centimeter cubed. And the last one, I have a trapezium here as my face. I have to add the 2 parallel sides, so that's 3 and 5. Divide that by 2 and times it by the height, which is 4. So if I do that, so 3 times 5 divided by 2 times by 4. 3 times 5 is 15. Divided by 2 is 7.5. Okay, 7.5 times 4 is 30. Okay, so this is equal to 30 centimeters squared. Let's write that down here, 30 centimeters squared. And I'll highlight it again. So this is the area that I've just found, all of this. Okay, and when I know the area of the cross section, what I need to do is multiply it by how long it is. So 30 times by 6 is going to give me my volume. So 30 times 6, and that's going to be 180 centimeter cubed. So the volume of each of these shapes, so the first one was 60 centimeter cubed, second one was 70 centimeter cubed, and the last one here is 180 centimeter cubed. Okay, just quickly again, find the area of the cross section and then multiply it by how long the shape is. Okay, this is because these are prisms and we're finding the volume. Okay, so the last thing we're going to be looking at is the area and the circumference of a circle. Now circumference I'm showing here with a C, and the area is A. Circumference is all the way around the circle. So if I start at this point and go all the way around, that is one circumference. Okay, an area, we know area is the 2D space inside here. Now the circumference formula, this one really comes from the idea that for every single circle, if I took the circumference and divided by the diameter, I always get pi. Okay, so that's where this formula comes from. So there's 2 that I can use. I will use both of them to show you how they work. So circumference is equal to pi times diameter. Pi d means pi times diameter. D here is for diameter, r here is for radius. Now my diameter, remember, is 1 point on the circumference to another point passing through the center. This time it's 10. So this is going to be equal to pi times 10. And when I put this in my calculator, I actually get a very long number. Okay, if I round it to 1 decimal place, so this is approximately now 31.4 centimeters. Now circumference is a length because it's all the way around like this, so 31.4 centimeters. Let's use the other formula so that you can see how that one will look. So circumference is equal to 2 times pi times radius. Now radius is half of the diameter. Radius goes from the center to the circumference in any direction. So diameter was 10, radius is 5. Okay, so 5 here. So let's put that in. So this is going to be equal to 2 times pi times 5. Now 2 times 5 is 10. So this really is the same as pi times 10. Okay, so and again, if I was to round it to 1 decimal place, I would get 31.4 centimeters. Now for the area. So area of this circle This one has one formula, okay, and it uses the radius, and I need to square it. So if the radius wasn't given here, if this wasn't shown to me, so let's say this was covered, so this wasn't there, and I'm given the diameter. The diameter is 10. So what I will do, I will write out the formula first, so pi times radius squared, and I can see that I can't use the 10 because that's the diameter, but I can find what the radius is because the radius is half of 10, because radius is always half of the diameter. So if 10 is the diameter, radius is 5. So r is equal to 5. So let's substitute that. So equals to pi times 5 squared. And when I do that, so if I put that in my calculator, what I will get is, I'll write some of the digits down here, 78.539816, and it carries on. And if I was to round it to one decimal place, it will be 78.5, okay? And this is in centimeter squared because we're looking at area and our measurements were in centimeters. Okay, so here are some for you to do. I've got a trapezium here, and I want you to find the area of this one. I want you to find the volume of these prisms that I have here. This one is a sketch of a circle with center here and radius 4. I want you to find the perimeter and area of this circle. This is a semicircle with a center here, and you can see that the diameter here is 12, and I want you to find the perimeter and the area of this semicircle as well.